To help us understand an idea about even and odd roots, let's look at a couple examples. We could look at the fourth root of a number. The fourth root, yeah, fourth root, 10th root, whatever it might be. As we're exploring this though, I want you to pay attention to the evenness or the oddness of the root or of the index. Here it is even. So what happens if I were to multiply a negative number times a negative times a negative times a negative? What is its result? Its result is a positive number. Then likewise, if I did 4 positive numbers, its result is positive. So that tells me if I have an even index, I need to ensure that my radicand is also positive or is positive. Therefore, we can get a solution. So the fourth root of 81, what number times itself 4 times? That would be a 3. 3 times 3 is 9, times 3 is 27, times 3 one more time is 81. Let's put the negative outside. Now we talked about earlier about this idea of negatives. Understand though, I have 2 different operations. The negative is outside of the operation, so my result will still be negative square root of, or the fourth root of 81, which is a 3. So my final result would be a negative 3, because the negative, again, was outside of my operation. The fourth root of negative 81. What do you think? Well, I kind of described here. I can't think of a number times itself by 4 times that will produce a negative result. We showed you earlier that 4 negatives produces a positive. 4 positives produce a positive. I can't get anything that produces a negative. So this one is undefined. Lastly, the fifth root of negative 32. The index here is odd. And we discovered earlier that I can have 5 positives or 5 negatives, or in this case, 5 negatives that will produce a negative radicand. Negative 32 is the same thing as negative 2 times negative 2 times negative 2 times negative 2 times negative 2. And that equals negative 32. So this result then, probably doing there, the fifth root of negative 32 would be a negative 2.